Welcome to our deep dive, everyone. We're going to be getting into the inner planets today.
Oh,
So,
yeah.
get ready to go beyond just the basics of these planets
Absolutely.
and really understand some of the more intriguing details of these planets,
Yeah.
um, like how different their temperatures can get from one to the other.
Right.
What makes our own planet Earth so special?
Right.
And what those rovers are up to on Mars these days.
Yeah.
All that good stuff.
It's going to be good.
And I have an expert here with me today who can connect all the cosmic dots for us.
It's a pleasure to be here.
Great.
Yeah. It's really fascinating to me that all these inner planets share a common origin story.
Oh, really?
Yeah. Just imagine back about 4.6 billion years ago,
Wow.
you've got this just giant swirling cloud of gas and dust, and gravity starts to pull this cloud together.
Okay.
And it creates this spinning disk and all the really dense materials they collect near the center of this disk. And that's where our rocky inner planets, they start to form from that.
So just to be clear, we're talking about Mercury, Venus, Earth, and Mars, right?
That's right. Okay, cool.
And you know what sets these planets apart from the outer planets?
Yeah.
Is that they're all terrestrial planets.
Okay.
They're primarily made up of rock and metal.
Touch.
They have solid surfaces. And they're much denser than those gassy outer giants like Jupiter and Saturn.
Okay.
And also they have very few or no moons
Oh, interesting.
and no ring systems.
Okay. So they're kind of like the solid, reliable members of the solar system family.
Yeah, exactly.
No flashy rings or, entourages of moons or anything like that.
Nope, just the basics.
Just get down to business kind of planets.
Yeah.
All right, cool. So let's start with Mercury,
Okay.
the smallest planet and the one closest to the sun.
Wow.
What's it like over there?
Well, Mercury's a world of extremes, I'll tell you that.
Okay.
It has almost no atmosphere.
Really?
Yeah. So it's got some really wild temperature swings.
Yeah.
Oh, wow.
During the day, it gets incredibly hot, like 800 degrees Fahrenheit.
Oh, my gosh.
And then at night, it plummets down to negative 290 degrees Fahrenheit.
That's a bigger temperature difference than any place on Earth.
Oh, absolutely. It's remarkable.
So why is that? Why such a huge swing?
Well, it all comes down to that lack of atmosphere.
Okay.
You see, on Earth, our atmosphere acts like a blanket.
Yeah.
It traps some of the sun's heat,
Uh-huh.
and it moderates those temperatures.
Yeah.
Mercury doesn't have that insulation.
Wow.
And on top of that, Mercury rotates incredibly slowly.
Oh, okay. So how slow are we talking?
Well, one rotation on its axis
Yeah.
takes 59 Earth days.
Wow.
So imagine a day
That's
that lasts for months. So
Yeah.
one side of the planet is just baking in the sun for this incredibly long time,
Yeah.
and the other side is freezing in darkness.
So it's like a cosmic oven on one side and a deep freezer on the other.
Exactly. That's a great way to put it.
Wild.
Yeah.
And no moons, right?
Nope.
Just Mercury out there doing its thing?
Yep.
All right, let's jump over to Venus then.
Okay.
The second planet from the sun.
All right.
Now, it's often called Earth's twin
Mm-hmm.
because of its similar size and structure.
Yeah, it's a pretty good comparison in that sense.
But I'm guessing that's where the similarities end.
Yeah, pretty much.
Okay, so what's different about Venus?
Well, Venus has this incredibly thick atmosphere,
Okay.
and it's mostly carbon dioxide,
Uh-huh.
and that traps heat like you wouldn't believe.
So you mean like what we're worried about with climate change here on Earth?
Yes, exactly, but on a much more extreme scale.
Oh, gosh.
Venus's atmosphere is so dense that it traps heat incredibly effectively.
Wow.
And as a result, the surface temperatures, they reach over 900 degrees Fahrenheit.
Kidding.
That's hot enough to melt lead.
Oh, my gosh. That's intense.
Yeah, it's a scorching world.
So Venus is like a cautionary tale about what could happen
Yeah, you could say that.
if a runaway greenhouse effect gets out of control.
Absolutely. It's a stark reminder of what can happen.
So what else is going on under that super thick atmosphere?
Well, Venus is a world of volcanoes.
Oh, wow.
Thousands of them dot the surface.
Really?
And some scientists believe that Venus could still be volcanically active today.
Wow.
And this volcanic activity, it might actually contribute to some of the strange atmospheric phenomena that we see on Venus.
Yeah?
And get this, it even rotates backwards.
What do you mean backwards?
The sun rises in the west and sets in the east on Venus.
You're kidding. Why is that?
Well, there are a few theories out there.
Yeah?
One idea is that early in Venus's history, it was hit by a massive object.
Oh, wow.
And that impact was so powerful, it actually flipped the planet's rotation.
Wow, that's wild.
Yeah, it's definitely one of the more peculiar features of Venus.
Absolutely. So Venus is full of surprises.
Yeah, you could say that.
All right. Well, let's shift our focus now to our home planet.
Okay.
Earth, the third rock from the sun,
Right.
the largest of the inner planets.
It is.
And as far as we know, the only one that supports life.
As far as we know, that's true.
So what makes Earth so special besides, being our home?
Well, it has a very unique set of conditions that make it perfect for life as we know it.
Yeah.
Earth's atmosphere is a key factor.
Yeah.
It's got this perfect balance of nitrogen and oxygen.
Mm-hmm.
And that balance, along with Earth's strong magnetic field, protects us from harmful radiation from the sun.
Okay.
And it keeps our planet at a comfortable temperature.
Yeah.
So we can have liquid water and all sorts of amazing life forms.
And then there's water itself,
Right.
which covers over 70% of Earth's surface.
That's right.
And it's essential for all life as we know it.
Absolutely.
I mean, we have everything.
Yeah.
Lush rainforests,
Yeah.
vast oceans, polar ice caps.
Yeah, it's remarkable.
It's just incredible how diverse our planet is.
It truly is.
And let's not forget Earth's faithful companion, the moon.
Ah, yes, the moon.
That's right. So the moon's gravitational pull is what creates our ocean tides.
That's right.
And that has shaped our coastlines and influenced life on Earth for, millennia.
Absolutely. The moon has played a huge role in shaping our planet.
And of course, we can't forget the historical significance of humans landing on the moon.
A truly remarkable achievement.
It was a monumental achievement that really sparked our imagination
Yeah.
and propelled us further into space exploration.
There is a giant leap for mankind.
Absolutely. So now let's move on to the fourth and final inner planet,
Okay.
Mars,
The red planet.
the red planet. A cold, dry world with a very thin atmosphere,
That's right.
mostly made up of carbon dioxide.
Yes. Primarily carbon dioxide.
And the average surface temperature is -81 degrees Fahrenheit.
Yeah, it's a pretty chilly place.
Brr. Mars has always kind of captured our imagination, though,
I agree.
especially with that possibility of, past or even present life.
It's a tantalizing thought, isn't it?
It really is. So,
Yeah.
so what kind of clues do we have about that?
Well, one of the biggest clues is the presence of polar ice caps.
Okay.
Now, these ice caps are made of water and carbon dioxide, and that hints at the potential for liquid water to exist on Mars, at least at some point in the past.
Okay, so you're saying Mars wasn't always this cold, dry desert that we see today?
That's exactly what I'm saying.
Oh.
Billions of years ago, Mars likely had a thicker atmosphere
Wow.
and liquid water flowing on its surface.
Wow.
Some scientists even believe that ancient Mars might have had a vast ocean
Really?
covering much of its northern hemisphere.
An ocean on Mars.
It's a pretty incredible thought,
It really is.
and the evidence for this is mounting.
Okay.
Our rover missions have found intriguing traces of organic molecules,
Okay.
which are the building blocks of life,
Uh-huh.
and these are preserved in Martian rocks.
That's amazing.
So while we haven't found definitive proof of past life on Mars just yet,
Yeah.
there's certainly a lot of evidence suggesting that it was once a habitable planet.
And we've sent a whole fleet of rovers to explore Mars,
That's right.
to try to unlock those mysteries.
Right.
And they've been beaming back all sorts of incredible data
Oh, yeah, tons of data.
about the Martian climate, the
Right.
geology,
Yeah,
and even signs of, that ancient life that we're talking about.
absolutely.
It's like having robotic detectives on the surface,
That's a great way to put it.
piecing together this history of this fascinating planet.
And they're doing a fantastic job.
That's so cool.
Yeah.
And Mars has two moons, right?
It does.
Phobos and Deimos.
That's right. Phobos and Deimos.
Yeah, those are different from our moon, right?
They are very different.
Okay.
So unlike our large spherical moon,
Yeah.
Phobos and Deimos are much smaller,
Okay.
and they're irregularly shaped.
Hmm.
They almost look like giant potatoes tumbling through space.
Really? That's so funny.
Yeah, they're quite the sight.
And they're behaving rather strangely too, right?
They are!
Like, what's going on with that?
Well, Phobos is gradually spiraling inward towards Mars,
Oh, wow.
and Deimos is slowly moving away.
So it's like this cosmic dance that we're still trying to figure out.
Exactly. It's a puzzle that scientists are working to solve.
That's wild. Okay, so we've got this diverse group of inner planets here.
Yeah, a fascinating bunch.
What stands out to you as the biggest takeaway so far?
Well, I think what's truly remarkable is that despite sharing a common origin story,
Yeah,
these four planets have evolved in such drastically different ways.
that's true.
You've got the scorching heat of Venus, the potential for past life on Mars.
Yeah.
It really showcases the incredible variety that can arise from a single cloud of gas and dust.
Yeah, it really highlights how dynamic and surprising our solar system is.
Absolutely.
Even within our own neighborhood.
Right, our backyard.
There's so much variation and so much left to discover.
There's always something new to learn.
That's so cool. And we talked about those planetary scarps earlier.
Right, those steep, cliff-like formations.
Yeah, so those are found on Mercury, Earth, the Moon, and Mars.
That's right. They're all over the inner solar system.
So tell me more about those like canyons.
Well, not exactly. Canyons are formed by erosion. But planetary scarps, they can actually result from a variety of geological processes.
Okay.
Things like tectonic activity, volcanic activity, or even the cooling and shrinking of a planet's crust.
So they're kind of like wrinkles on a planet's face.
You could say that.
As it gets older.
Yeah, sign of age and experience.
And by studying these scarps, we can actually uncover clues about a planet's history, right?
Absolutely. It's like reading a geological record written in the rocks.
That's really cool. So we've got these seemingly barren landscapes.
Yeah.
But they're holding all these clues to the past.
Secrets waiting to be unlocked.
It's like a cosmic puzzle waiting to be solved.
And we're putting the pieces together one by one.
I love that. I'm ready to dive even deeper.
Let's do it.
Into the specifics of each of these planets.
I'm excited to share what I know.
Awesome.
So let's zoom in now on some of those, finer details that make each of these inner planets so unique.
Sounds good.
Yeah.
I'm ready for my my planetary close-up. Let's start with Mercury.
Okay.
We talked about those extreme temperatures and the lack of atmosphere.
Right.
But what else makes this tiny planet stand out?
Well, one thing that really sets Mercury apart is its unusual composition.
Oh, okay.
It has this surprisingly large iron core relative to its size.
So it's like a giant metal ball.
Yeah, pretty much.
With a thin, rocky shell.
Yeah, you could think of it that way.
How did that happen?
Well, there are a few theories floating around out there.
Yeah.
One idea is that, early in the solar system's formation, Mercury might have been struck by a massive object.
Oh, wow.
And this impact was so powerful that it blasted away much of its outer layers.
Oh, wow.
Leaving behind mostly an iron core.
Like a cosmic billiards game.
Exactly.
It makes you wonder what other dramatic events shaped these planets.
Oh, absolutely. There were some wild times back then.
Wild times in the early solar system.
Yeah.
All right, well, if we shift our focus over to Venus, then we see another planet with, its own kind of dramatic story to tell.
Absolutely.
Beneath that thick, toxic atmosphere lies a volcanic landscape unlike anything we see here on Earth.
It's pretty remarkable.
And we talked about these volcanoes a little bit earlier. What makes them so unique?
Well, for one thing, Venus has a ridiculous number of volcanoes.
Okay.
Thousands of them scattered all across its surface.
Really?
Yeah. And while most of them appear to be dormant, some scientists believe that volcanic activity is still ongoing on Venus.
Oh, wow.
And this could explain some of those strange atmospheric changes that we've observed over the years.
Volcanoes erupting on another planet.
Yeah, it's a pretty wild thought.
I can only imagine what that must look like.
Oh, it would be an incredible sight, I'm sure.
Yeah, and to add to the mystery, Venus also has these unique features called corona.
Ah, yes, the corona.
What are those?
So these are vast circular structures that can be hundreds of miles across.
Hundreds of miles?
Yeah, they're huge.
So are they like super volcanoes or something?
Not quite.
Okay.
They're thought to be areas where plumes of hot material from deep within Venus's interior are pushing up against the surface.
Right.
And this causes the surface to bulge and crack.
Oh, wow.
So imagine like a cosmic blister slowly rising and spreading across the landscape.
That paints a very interesting picture.
It's quite the sight to imagine.
So Venus is a world of extremes.
Oh, yeah.
Intense, heat-crushing pressure, volcanoes erupting, and these massive corona just reshaping the surface.
And this is a planet that's constantly changing and evolving.
It's a reminder that even within our own solar system, there are worlds that are just dramatically different
absolutely
from our own.
It's one of the things that makes exploring our solar system so fascinating.
Yeah, absolutely. All right, well, let's turn our attention back to our home planet.
Right back to Earth.
Earth makes our blue marble so unique.
Well, I think one of the most striking things about Earth is the incredible diversity of life that we find here.
Yeah, that's true.
From microscopic organisms to giant whales, lush rainforests to barren deserts. It's truly remarkable.
It is. And that biodiversity is made possible by this, unique combination of factors.
Really?
I mean, Earth's distance from the sun,
Right.
the presence of liquid water, our protective atmosphere, the planet's magnetic field.
It all works
All
together.
of these things working together.
Yeah, in this delicate balance that allows life to thrive.
We often take our atmosphere for granted,
Yeah, I think that's true.
but it really is a marvel.
It is.
It protects us from harmful radiation, it regulates temperature, provides the air we breathe.
All essential for life.
I've heard that the composition of our atmosphere has changed over billions of years.
Oh, that's absolutely true.
Is that right?
Yeah, it's fascinating to think about how our atmosphere has evolved over time. Early Earth's atmosphere was actually very different from what we breathe today.
What was it like?
Well, it was rich in carbon dioxide
Okay.
and other gases that were released by volcanic eruptions.
So not very breathable.
Not at all.
But over time, life itself began to change the composition of the atmosphere.
That's right. Life played a key role in shaping our atmosphere.
So you mean like plants and other organisms started producing oxygen?
Exactly. The evolution of photosynthesis
Yeah.
was a turning point in Earth's history.
Photosynthesis, the process by which plants use sunlight
That's right.
to convert carbon dioxide into oxygen.
Exactly.
Right.
It gradually transformed the atmosphere into the oxygen-rich environment we have today.
Wow. So life actually created the air we breathe.
In a way, yes.
That's amazing.
And that paved the way for the evolution of complex life, including us.
Life creates life. That's amazing.
It's a beautiful cycle.
All right, let's shift our attention now to Mars.
Okay. Back to the red planet.
Back to the red planet. We talked about the potential for past life on Mars.
Right. One of the most intriguing aspects of Mars.
It is. So what evidence have we found that supports that idea?
Well, one of the most exciting discoveries has been the evidence of ancient riverbeds,
Oh, wow.
dried up lake beds,
Okay.
and even minerals that form in the presence of water.
So that suggests...
It suggests that Mars was once a much warmer and wetter planet than it is today.
Wow. So Mars wasn't always this cold, dry desert?
Exactly. Billions of years ago,
Yeah.
Mars likely had a thicker atmosphere
Okay.
and liquid water flowing on its surface.
Huh.
Some scientists even believe that ancient Mars might have had a vast ocean covering much of its northern hemisphere.
An ocean on Mars, that's incredible.
It's quite a thought, isn't it?
It really is. It paints a very different picture from the planet we know today.
It does indeed.
And the evidence keeps piling up, right?
Oh, absolutely.
Like those rover missions that we've sent.
Right.
They found intriguing traces of organic molecules in Martian rocks.
That's right. Those building blocks of life.
That's incredible.
It is.
So while we haven't found, definitive proof of past life on Mars yet,
Not yet.
there's certainly a lot of evidence suggesting that it was once a habitable planet.
The evidence is very compelling.
Wow. And I know we've sent a lot of different rovers to Mars over the years.
We have. It's been a very active area of exploration.
It has. Can you tell me a bit more about those?
Sure. So the rovers have really been our eyes and ears on Mars.
Yeah.
They've allowed us to explore the planet in this unprecedented detail.
Okay.
And it all started with Sojourner back in 1997,
Oh, yeah?
the first rover to successfully land on Mars.
Yeah.
It was a small six-wheeled robot,
Uh-huh.
but it really paved the way for future missions.
I remember those twin rovers.
Ah, yes, Spirit and Opportunity.
Spirit and Opportunity landing in 2004.
Those were fantastic missions.
And they were designed to last for just 90 Martian days.
Yeah, just 3 months.
But they ended up exploring the planet for years.
They did. They far exceeded expectations.
That's amazing.
Spirit lasted for 6 years, and Opportunity an incredible 14 years.
Wow.
They found evidence of past liquid water.
Uh-huh.
They explored vast craters and plains.
So they really gave us a much better understanding of Mars.
They did. They were pioneers in Martian exploration.
And then there's Curiosity,
Ah, yes, Curiosity, a real workhorse.
which landed in 2012.
Right.
That rover is about the size of a small car.
Yeah, it's a big one.
And it's packed with all sorts of scientific instruments.
Oh, it's a mobile laboratory.
What's it been up to?
Well, Curiosity has been exploring Gale Crater,
Okay.
a site that scientists believe was once a lake.
A lake.
Yeah, a long time ago.
Wow.
It's been analyzing rocks, drilling samples, even taking selfies.
It takes selfies.
Oh, yeah, we've got some great pictures of Curiosity on Mars.
That's so funny.
It's found evidence of ancient streams,
Okay.
organic molecules, and even methane gas in the Martian atmosphere.
Wow, so it's really uncovering the secrets of Mars.
It's doing a phenomenal job.
And now we have Perseverance.
Ah, yes, the latest and greatest.
The newest rover, which landed in 2021.
That's right, a very sophisticated machine.
But what makes this one so special?
Well, Perseverance is on a very specific mission.
Oh,
It's searching for signs of ancient microbial life
oh wow.
in Jezero Crater,
Okay.
which was once a lake and river delta.
So it's really looking for evidence of past life.
Exactly, that's its primary objective.
And it's equipped with a drill, right?
What's this?
To collect rock and soil samples.
Right.
That'll eventually be returned to Earth for analysis.
That's the plan. We're going to bring pieces of Mars back to Earth.
That's incredible. So we could actually have samples of Martian rock and soil
Yeah, it's an ambitious project, but it's underway.
in the near future here on Earth.
That's the goal.
Wow. And Perseverance is also testing technologies for future human missions to Mars, right?
Absolutely.
Like producing oxygen from the Martian atmosphere.
That's right. We need to figure out how to live off the land if we're going to send humans to Mars.
It's incredible to think that we're getting closer and closer to sending humans to Mars.
It's an exciting time to be involved in space exploration.
It's like something out of science fiction.
It really is. Science fiction is becoming reality.
But even as we, look to the future,
Yeah.
I think it's important to reflect on how far we've already come
I agree.
in our understanding of these inner planets.
Absolutely. We've learned so much in just the past few decades.
We've explored the scorching plains of Mercury,
Yeah.
the volcanic landscapes of Venus,
Mm-hmm.
the diverse ecosystems of Earth,
Right.
and the intriguing evidence of Mars's wetter past.
It's been an incredible journey of discovery.
It really has. What stands out to you as the most,
Yeah.
surprising or intriguing fact that you've learned?
That's a tough one. There's so many to choose from.
Yeah, it really is amazing how much we've learned about these inner planets.
It is.
From scorching temperatures to ancient riverbeds,
Mm-hmm.
it really makes you realize just how diverse and dynamic our solar system is.
Absolutely. Every corner we turn, there's something new and fascinating to discover.
Okay, so we've explored each planet kind of individually now.
Right. We've gotten a good look at each one.
But now I'm kind of curious about the bigger picture.
Okay. Yeah.
Are there any common threads that you see that tie these inner planets together?
That's a good question.
Besides, their shared origin story.
Well, besides those planetary scarps we discussed earlier,
Yeah.
one striking commonality is the role that volcanoes have played
Oh, what?
in shaping these worlds.
You mean like those massive volcanoes on Venus and Mars?
Exactly. Volcanoes are a powerful force in planetary evolution.
Okay.
They release gases from a planet's interior,
Yeah.
shaping its atmosphere and even influencing its climate.
Okay.
Think about Venus with its thick, hot atmosphere,
Right.
largely created by volcanic outgassing over billions of years.
That's right. We talked about how Venus's volcanoes might still be active today.
Yeah, there's evidence to suggest that.
And on Earth, volcanic eruptions have played a role in both creating and destroying life.
Absolutely. Volcanoes are both creative and destructive forces.
That's true.
They can spew out gases that make a planet uninhabitable,
Yeah.
but they can also release nutrients that enrich the soil and create fertile ground for life to flourish.
Yeah, so it's like this delicate balance between fire and life.
It is a balance, a constant interplay of forces.
So volcanoes have had a big impact
Huge impact.
on shaping the atmospheres and even the habitability of these planets.
They've played a key role.
What about the atmospheres themselves?
The atmospheres, yes.
I mean, we've seen such a range
A huge range.
from almost nothing on Mercury
Right.
to a super thick blanket on Venus.
Yeah. It's incredible the diversity we see.
That's a great point. So these atmospheres are kind of like fingerprints,
Yeah, a good analogy.
revealing clues about their histories
Mm-hmm.
and, the processes that shape them.
Exactly. Each atmosphere tells a story.
So let's see, Mercury being so close to the sun
Right.
and having a weak magnetic field,
Yeah.
it lost most of its atmosphere to the solar wind.
That's right. The sun just kind of stripped it away.
So it's like the sun just blew away Mercury's atmosphere.
You could say that the solar wind is a powerful force.
Yeah, and then there's Venus, which went in the opposite direction.
Right. Venus went the other way.
Developed this super thick atmosphere.
Yeah. Almost 100 times denser than Earth's.
And it's mostly carbon dioxide, right?
Mostly carbon dioxide, yeah.
And that creates a runaway greenhouse effect,
Exactly. Trapping heat and making Venus the hottest planet in our solar system.
which we talked about how that's kind of a cautionary tale
Yeah, a reminder of what can happen.
about the dangers of a runaway greenhouse effect here on Earth.
Absolutely. It's a valuable lesson to learn from our neighbor.
And then there's Mars, which has this very thin atmosphere.
Right. Mars lost most of its atmosphere over time.
What happened there?
Well, scientists believe that Mars once had a thicker atmosphere,
Okay.
perhaps even similar to Earth's early atmosphere. But over billions of years, it lost most of it to space.
Why would that happen?
Well, one theory is that Mars's weaker gravity,
Okay.
combined with its lack of a global magnetic field,
Yeah.
allowed the solar wind to strip away its atmosphere.
So a planet's gravity and magnetic field really play a crucial role in holding on to its atmosphere.
They're essential for atmospheric retention.
And a planet's atmosphere can determine its temperature,
Right.
its weather patterns, and ultimately its potential for life.
It's all connected.
It really is amazing how interconnected everything is.
The universe is a complex web of relationships.
We've covered so much in this deep dive,
We've taken a grand tour of the inner solar system.
exploring each of the inner planets in detail, comparing their unique characteristics,
Yeah.
and even pondering the possibility of, terraforming Mars one day.
That's right. We've covered a lot of ground.
What's the one big takeaway you hope our listeners walk away with?
I think the most important takeaway is the realization that we live in a vast and wondrous universe
Yeah,
filled with incredible diversity.
that's true.
Even within our own solar system,
Yeah.
we find a stunning array of planets,
Uh-huh.
each with its own unique story to tell.
Absolutely. And by studying these worlds,
Right.
we gain a deeper understanding of our own planet's origins,
Yeah.
its evolution,
Yeah.
and the precious conditions that make life possible.
It's a humbling and inspiring perspective.
Beautifully said.
Oh.
And to add to that, I think it's important to remember
Yeah.
that we're still in the early stages of exploring our cosmic backyard.
Oh, absolutely. We're just getting started.
There are countless mysteries yet to be solved.
Countless discoveries waiting to be made.
Each mission we send,
Yeah.
each observation we make,
Uh-huh.
pushes the boundaries of our knowledge
It does.
and sparks our imagination.
And that's what makes it all so exciting.
Oh, that's so true. Well, this deep dive into the inner planets has been a fantastic journey.
It has been a pleasure exploring with you.
Likewise. And hopefully you, our listener, have learned something new,
Yes.
ignited your curiosity, and maybe even started dreaming of future explorations.
Keep looking up. Exactly.
There's so much more to discover.
Until next time, keep exploring.
Keep questioning.
And keep looking up.
That's the key to unlocking the secrets of the universe.